Welcome to my channel. This is a small to medium enterprise fire pump room in a high-rise building. The fire pump room is basically where the pumps that maintain the pressure in the fire system pipelines, the entire building. In this place, we have the fire pump, the diesel pump, and the jockey pump. We also have the controller panels that manage these pumps using pressure switches that send them feedback from time to time. As you can see at the far end there, that is the main suction pipe that is coming from the roof tank above the building. Let's get closer. You can see this comes from the roof tank, comes down. This is the suction line, which is the supply line of the water into the fire pump room. It makes a junction here, a T-junction, which branches out into a diesel pump, and then the next one is a branch which also enters into the electric pump, and then the last one is also a branch which branches into a jockey pump. Ordinarily, these junction points are supposed to be locked. You can see there is a valve there, a normally open valve, locked in open position. You can see the chains locked in open position. These valves ensure that water supply is available from the tank into the pumps in readiness for an emergency. So water supply coming from the roof tank comes through this main suction line and then branches out into these pumps. And then when it gets at the jockey pump end, it passes through this other valve here, also supposed to be normally open, and it's also supposed to have a chain. Unfortunately, this one does not have. It goes into the jockey pump. On the other side of the jockey pump, which is the discharge side, you have a pipe that goes up. The same thing happens with the diesel and the electric pump. This is the electric pump. From here into the electric pump this is a non-return valve. This non-return valve ensures that water coming from the tank never goes back into the tank. And then on the other part, which is the discharge side, we have the delivery side or the discharge side. There are two gauges here. This measures the pressure of water on the suction side, while the upper one measures the pressure of water on the discharge side. And then at this point, there is a branch out. If you look out, there is a branch out there which goes to your left. That branch out is supposed to be for return, bypass, for testing purposes. You can see it branches out, and it's always supposed to be in locked position. It's supposed to be in locked position. The bypass goes back into the tank at the roof. The bypass is normally meant to be used for test purposes. And then at the T-junction here, you have this branch out from, this is the common pipe on the discharge line that goes, this is the common pipe on the discharge line that goes straight into the building, supplying the sprinklers, the fire hydrants, and the other fire requiring purposes. Now, in case of emergency, what happens is that as water is being lost, let me get closer. As water is being lost, let's say a sprinkler point. Let me have an example of a sprinkler. For instance, now, here's a sprinkler. Let me give you a scenario of a situation where the pump room becomes very, very relevant. That's a sprinkler there. In case of emergency, let's say there is heat in a room or there is a fire situation in a room, the sprinkler has a bulb that explodes depending on the temperature setting that it is designed for. If it's in a kitchen, the temperature is usually higher. If it's in a normal space like a room, the temperature is lower for it. The temperature at which it explodes is lower. So when that bulb in the sprinkler explodes, it discharges water. As the water is discharged in that space, what happens is that the jockey pump here senses, the jockey pump senses the loss in pressure and kicks up. Once the jockey pump kicks up, it tries to fill back the water into the pipeline. And when the pressure continues to drop at a certain temperature of, at a certain pressure of about 1.6 bars, minus 1.6 bars, the jockey pump kicks up and starts to supply water, push water back into the pipelines in order to fill up the space or the water that has been lost. This continues, it continues in that way until the pressure gets to about 5 bars. At a temperature, as a pressure loss of 5 bars or minus 5 bars, the electric pump kicks up. This is the electric pump. And when the electric pump kicks up, it continues to pump water back into the pipelines, sucking water at a high pressure through these suction lines, right in here, and then keeps sucking from here, sucks water from here, you can see, sucks water from here, pushes it up, back into the building, to maintain the original pressure that was in the pipeline. This continues until such a point where either the jockey pump is either the electric pump is no longer capable of continuing, or there is loss of power supply, before the diesel pump will take over. And the diesel pump continues to pump this water to fill up those pipes and to maintain the pressure in the pipelines until such a point where that loss of pressure is stopped or human intervention comes in. So this is typically how this works. So this is a typical pump room, though not a very large one. But let me also talk about a test scenario here. Normally, in order to test the functionality of these pumps, which is usually done on a weekly basis in some establishments, you need to cut off pressure or water coming from the main suction line, which is this. You need to cut off water coming from the main suction line, and then you will gradually release the bypass valves. Look at the bypass valves. You gradually release the bypass valves. If, for instance, you start with releasing the bypass valve gently for the electric pump, when you do that, you gradually release this valve. As you are releasing this valve, and water is, as you are releasing it, water is being dropped back into the return pipe or the return part of the tank. And once this pressure in the pipeline drops to about minus 1.5, the jockey pump kicks up. Jockey pump kicks up. And if the drop in pressure, so as soon as the pressure drops to about minus 5 bars, the electric pump kicks up and begins to push water back into the pipeline, back into these pipelines, in order to compensate for the water that has been lost from the discharge system. And if this situation continues, the jockey pump continues to pump water back into the pipelines to ensure that water gets to all the sprinklers, and the same room where water is, maybe there is a fire, it continues to maintain that pressure so that that fire will be quenched. If nobody intervenes and that pressure drop is not contained, this will continue until such a point where the jockey pump is no longer capable of pushing this water. Then the diesel pump will come on. The diesel pump is for the final emergency in case there is loss of power supply. That's why when the diesel pump kicks up. In case of certain situations where the electric pump cannot function, the diesel pump kicks up and maintains this same performance. But you have to understand that during testing, this has to be opened gently. When you open it gently, these valves have to be opened gently so that this test can go on. At the conclusion of the test, it must be ensured that these valves are returned back to their off state and locked, to their closed state and locked. And the valves of the suction should also be brought back into their open state, as you see, and chained. You can see. Thank you for watching my channel.